Today we're going to talk about a really important concept in trig, and that's a concept of the unit circle and what the unit circle has to do with the sine, cosine, and tangent of a particular inscribed angle. Well, first of all, let's define what the unit circle is. The unit circle is a circle with the center at the origin. So I have a picture right here. This center is, here's the y and the x-axis, and the center is at the origin, and the radius is of length 1. So it's a really tiny circle because the radius is 1. If you took a look at the graphing calculator, I zoomed in a little bit. So each one of these tick marks is 1. So this would be 1, 0, 0, 1. So if I wanted to draw a unit circle on the graphing calculator, I could just use this circle command that exists there. The center is at 0, 0, and the radius is at 1. So here's a unit circle. It's very small, and it intersects the x and y axis at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So it's really small. So what I've done is I've blown up this unit circle a little bit, but there are some really important points on it. Over here, this point, in a different color, this point over here is 1, 0, because the radius is 1. This point up here is 0, 1. Back here, this point is negative 1, 0. And down here, this point is 0, negative 1. So those are 4 really important points on the unit circle. Now there are an infinite number of points on this unit circle. I'm just going to pick a point right here. I'll call this point P. P stands for point. And the point on this unit circle has an x and a y coordinate. So I go over x and up y, and I get to point P. Well, this point P can be anywhere on this unit circle in any of the 4 quadrants. But what I'm going to do is I'm going to talk about an angle. And this angle is the Greek letter theta. Theta is this, it's an O with a little line through it. And this angle right here is the standard position like we talked about before. This angle, theta, it starts here on the x-axis and it goes up to here. Here's the terminal side. And the terminal side of this angle theta corresponds to where it intersects the unit circle at point P. So here's a nice little angle right here, theta. Really important angle in standard position. And so what I'm going to talk about today is I'm going to talk about the 3 major trig functions of this angle theta: the sine of theta, the cosine of theta, and the tangent of theta. And what we're going to do to figure this out is we're going to drop a perpendicular down to the x-axis, straight down to the x-axis, and what we've just done is we've created a right triangle. In this right triangle, the 3 sides, according to this standard position, theta, the 3 sides directly opposite. Here's the opposite side. This is the right triangle, so this is the hypotenuse. This terminal side is the hypotenuse of this right triangle. And down here, this side down here is called the adjacent side. So we've got adjacent, opposite, hypotenuse of this right triangle, and the angle in standard position is theta. So now what we're going to do is we're going to define the sine, cosine, and tangent of this angle theta according to this right triangle. Well, you remember Sohcahtoa. Hopefully you remember how to spell it. Whoops, and I always spell it wrong too. Sohcahtoa. This says sine is opposite over hypotenuse. Well, we know how long these sides are because what we have is the length of this adjacent side here is just the x value of this point P, because if you go over x, then you know you have this x value right here. So this adjacent side right here is this x value. This length from here to here is this x value. From here to here, the length of this leg of the right triangle, well, how high did we go? Well, we went up y. So this opposite side is of length y. Whatever this y value is on this point, we go over x, up y, and we get to the point P. And how long is the terminal side of this angle theta? How long is the hypotenuse of this right triangle? Well, since this is on the unit circle, all of the radius, every single radius is of length 1. So this hypotenuse, this radius is equal to 1. So the length between here and here is 1. All of these radius have a length 1. So now to use Sohcahtoa, the sine of this angle, remember, is the opposite side divided by the hypotenuse. Well, the opposite side we just said was y. That's of length y, this y value of the point P. And the hypotenuse is always 1. Well, what's y over 1? Oops, sorry. What's y over 1? Well, y over 1 is just y. So the sine of this angle is this y value right here of this point P. Cosine of theta is the adjacent side divided by the hypotenuse. Adjacent over hypotenuse, well, let's see, the adjacent side is of length x. The hypotenuse is of length 1. So the cosine of this angle is x over 1, which is just equal to x. And now let's talk about the tangent. Tangent is opposite over adjacent. Well, the opposite side is y. The adjacent side is x. And what is y over x? Well, y is the sine of theta. They're equal to each other. X is the cosine of theta. And y over x, the tangent of any angle, is the sine of that angle, theta, divided by the cosine of that angle, theta. Sometimes I like to put parentheses around the sine and cosine. So this is really important. Any point on the unit circle, it doesn't matter where we go around this unit circle, you can pick any point. Any point on the unit circle can be found, and we'll do some examples of this, that the x value is the cosine of that angle theta. The y value is the sine of that angle theta. And if we know, if we know this theta is 30 degrees, for example, we know that this point is the sine of 30, which we can find on the calculator. I'm sorry, the cosine of 30, comma, sine of 30. So we'll do some examples down here, but again, this is really, really important. And I'm just saying it again, what we just said here, I'm saying it in here in bold, that if any point on the unit circle, like all of these points down here, the x value is the cosine of the angle and the y value is the sine of the angle. So this is really important. Put some stars around it. So let's take a look at some point P. I'll just put a P for point. Here's a point called negative 0.7. So here's a 0.7 and up 0.7. And what we're doing is we're drawing this angle theta in standard position. So I'll just put a theta in there. Remember, you start on the x-axis. Let me zoom in a little bit here. So this angle theta, what is the sine? Well, the sine is the y value. And this y value is equal to 0.7 right here. Here's y. What is the cosine of this angle? Well, the cosine of the angle is the x value. And what is the x value of this point? This x value is negative 0.7. And what is the tangent? Well, up here we said the tangent was y over x. Or in other words, sine over cosine. So the tangent, we'll just call this y over x. Y over x is equal to 0.7 over negative 0.7, and anything over itself is 1. And we have a positive over negative, so that would be negative 1. So the tangent of this angle theta, whatever it is, and we can figure it out. All right, here's another point P. Here's a point P down in quadrant 4. This other one was in quadrant 2. Here's quadrant 4. And now we have this big old angle all the way around in quadrant 4. The sine is the y value. The y value is negative 0.5. The cosine is the x value. The x value is 0.866. And the tangent is y over x, or sine over cosine, which is negative 0.5 over 0.866. And I don't know what that is, so I'm going to grab my calculator and ask it. Negative 0.5 divided by 0.866 is negative 0.5774. I guess I'll round it to 4 decimal places. Negative 0.5774. Now over here we have another point P on the unit circle. This point is in quadrant 3. Well, the sine is the y value. The y value, this y value is negative 0.49. The cosine is the x value. The x value is negative 0.87. And that makes sense, hopefully. Oh, let's draw this angle theta in standard position. And it makes sense that the x and the y are both negative because you're going to the left and you're going down. So x and y both have to be negative. So tangent is y over x. And I don't know what negative 0.49 divided by negative 0.87 is, but my calculator can tell me. And that is negative 0.5632, or positive 0.5632. So we've got here negative 0.49 divided by negative 0.87 y over x, which is 0.5632. A little blurry here. And there's page 5. Now let's move on to page 6. So what we're going to do is we're going to find sine, cosine, and tangent of any angle, and this angle is on the unit circle in case 1, on the unit circle, just like what we did before. So if point P, like we said before, point P, I've given you 3 point P's down here. If point P is on the unit circle, now remember O is the origin, so OP is the terminal side. Remember, point O is the origin, so we've got a terminal side. What we're going to do is find the sine, the cosine, the tangent, and the quadrant of this angle. So here we go, point P. So I'm just going to draw a real quick unit circle here. And this point P is over 9 over 41, whatever that is, and up 40 over 41. Those are both positive. So here's point P. Looks like positive, positive. So I'll draw this little terminal side and this angle theta. So remember, the sine of theta is the y value, and the y value is 40 over 41. Cosine is the x value. The x value is 9 over 41. And remember, tangent is y over x. So this becomes a complex fraction, but it's really not too bad, because when you have 40 over 41 divided by 9 over 41, all you have to do is multiply the top and bottom by 41, because that's the LCD. The 41s are going to cancel, and what you're left with is 40 over 9. And what quadrant is this in? This is in quadrant 1, and we'll just use Roman numerals for the quadrants. Okay, we've got another point P on the unit circle. This one's got a negative x value. So here's my unit circle. Now if you've got a negative x value and a negative y value, gosh, we must be down here, because negative x, negative y. So we've got this angle theta going down and connecting here to point P. Well, the sine of theta is actually the y value. The y value is negative 7/25. The cosine is the x value, which is negative 24 over 25. Tangent is y over x, which is equal to negative 7/25 divided by negative 24 over 25. Well, we've got our least common denominator already of 25, so if we multiply the top and bottom by 25, the 25s will cancel, and we're left with negative 7 over negative 24. Negative 7 over negative 24 is positive 7/24. And what quadrant did we land in? We landed in quadrant 3. The next one, sine. I'm not going to draw this because we already know sine is the y value. The y value is negative 2 square root of 5 over 5. The cosine is the x value, which is the square root of 5 over 5. And the tangent is y over x, negative 2 square root of 5 over 5 divided by square root of 5 over 5. And if we multiply both the x, or the top and the bottom, by 5, canceling out the 5's, we're going to get negative 2 square root of 5 over the square root of 5. And those square root of 5's can cancel, so all we're left with is negative 2. So the tangent is negative 2. And what quadrant did this land in? Well, if you have a positive x value and a negative y value over, well, let's draw the unit circle. If you go over positive and down, you're going to get down here. Here's point P down here, and point P ends up in quadrant 4, just because it's positive x and negative y. Oops, positive x, negative y. All right, now let's talk about for the quadrantal angles. This angle right here in standard position, this angle is 0 degrees, right? Because we haven't gone anywhere. Let's just quickly go through all of these angles. Let's just draw our little angle theta here. I think I'll do this in red. This angle theta, hopefully you know that this angle is 90 degrees. It's a right angle. Over here, if you start on the standard, the standard position of this angle, starting over here, we have angle theta is 180 degrees. Remember, quadrantal angles are just multiples of 90. And if you start over here, like always, come around to here, this angle is 270 degrees, which is also the same as negative 90 if we went in the other direction. So, because we have these points on the unit circle, this point is 1, 0. Remember, the sine is the y value. This y value is 0. So the sine of 0 degrees is 0. Right? The sine of theta, theta is 0. All right, the cosine is the x value. Well, the x value is 1. So what are we saying? We're saying the cosine of 0 degrees is equal to 1, because it's the x value. And the tangent is y over x, which is 0 over 1. So this means that the tangent of 0 degrees is equal to 0 over 1, which is just 0. Okay, now we've got theta's 90 degrees. Now here we've got the x value of 0 and the y value of 1. So the sine of theta is the y value. This y value is 1. So what that means is the sine of 90 degrees is 1. And you can even ask your calculator that if you want. Make sure you're in degrees mode. And if you do a sine of 90 degrees, it'll tell you 1. Like if you do a sine of 0 degrees, it'll tell you it's 0. All right, and the cosine of 90 degrees, the cosine is the x value. The x value is 0, so that means the cosine of 90 degrees is equal to 0. Calculator will also tell you that cosine of 90 degrees is equal to 0. And the tangent is y over x. And 1 over 0, anything over 0 is undefined, right? If you have 1 over 0, you get an error, divide by 0. Or if you do the tangent of 90 degrees, your calculator will tell you that you can't do it, there's an error. It just means it's undefined. Tangent, the tangent of 90 is undefined. Now we've got 180 degrees. The sine is y. This y value is 0, so that means the sine of 180 degrees is 0. Your calculator will tell you that. The cosine is the x value. The x value is negative 1. So what does that mean? It means the cosine of 180 degrees is negative 1. Tangent is y over x, which is 0 over negative 1. You can divide 0 over anything, which is 0. So that means the tangent of 180 degrees is equal to 0. You can ask your calculator all this. Let's ask our calculator about the cosine of 180. That's a different one. Let's see. Oops. Cosine of 180. Negative 1. Sine 180. 0. Tangent, 180, 0. So your calculator can tell you, or you can go to the unit circle. And last but not least, we've got 270 degrees. The sine is the y value. The y value is -1. That means the sine of 270 degrees is -1. The x value is 0. It means the cosine of 270 degrees is 0. Tangent is y over x, which is -1 over 0, which again is undefined. So we can ask about the sine of 270, -1. The cosine 270 is 0, and the tangent of 270, you'll get an error message. Error. So those are pretty important. Quadrantal angles. We've got the sine, cosine, and tangent of all of these. Now the last page. Whew, this is a long one. The last page. Quadrantal angles. Okay, we've already covered this on the other page. So all we really have to do is go back here and talk about the sine, cosine, and tangent. I guess because these are so important, I wanted to do this again. So we've got this as 1, 0. This point on the unit circle is 0, 1. This point is -1, 0. And this point down here is 0, -1. So if we want to go to the cosine of 180, we go over here. This is 180 degrees. This up here is 90 degrees. Here's 270 degrees. And here's 0 degrees, or 360. And so the cosine of 180, the cosine is the x value, which is -1. The sine of 180 is the y value, which is 0. The sine of 270, remember the sine is the y value, so that's -1. The cosine of 360, cosine is x, so the cosine of 360 is 1. 90 degrees is up here. The sine is the y value. The y value is 1. Now -90, remember -90 comes down here. -90 is the same thing as the sine of 270 degrees. And the sine of 270, remember, sine is y, so that is -1. Tangent of 180 is y over x. 0 over -1 is 0. The tangent of 270, the y over x value over here of 270, y is -1, x is 0. This is undefined. And the tangent of 360, the y over x value of 360 degrees is 0 over 1, which is 0. So these are just, again, re-emphasizing what we just did. All right, now the last thing, signs. This is not the sign. This is a sign, positive or negative. Okay, there's a little phrase called "all students take chemistry." And it's just a funny little phrase. It's not true, but it's just a way to remember what it means is what we're going to do when we see all students take chemistry is we're going to use the first letter of each word. And in quadrant 1, 2, 3, and 4, we're going to put the first letter. All students take chemistry in quadrant 1, 2, 3, and 4. Okay, in quadrant 1, A stands for all three trig functions. The trig functions are sine, cosine, and tangent. All three of them are positive. So quadrant 1, A stands for all. So all three trig functions, sine, cosine, and tangent, I don't know what this so means, they are positive. S stands for sine. Not this sine, but the sine. Sine, the sine of an angle in quadrant 2 is positive. Only the sine. Cosine and tangent are negative in quadrant 2. Now T stands for tangent. tangent is positive. The tangent of any quadrant 3 angle. So that means that the cosine and sine are negative for any quadrant 3 angle. And in quadrant 4, C stands for cosine, so cosine is positive. So sine and tangent are negative. Okay, so it's the sines and the quadrants. All students take chemistry. You are going to put an ASTC. Every time you see all students take chemistry, all students take chemistry. Okay, it means sine, cosine, tangent of angles in quadrant 1 are positive. That's what A means. Students means sine of quadrant 2 angles are positive. I guess I'm just saying the same thing again. T, tangent. Tangent of quadrant 3 angles are positive. C, all students take chemistry. Cosine of quadrant 4 angles are positive. Everything else is negative. All right, so what we're going to do now is the last thing is what quadrant, 1, 2, 3, or 4, what happens if the sign less than 0 means negative, greater than 0 means positive? Well, if the sine of an angle is negative and the cosine is positive, well, where is sine negative? Well, the sine is negative in quadrants 3 and 4 because it's positive in quadrants 1 and 2. Negative in 3 and 4 for the sine. So this, I'm going to not use Roman numerals, I'll just use regular numbers. So the sine is negative in quadrants 3 and 4. The cosine is positive in quadrants 1 and 4. So which 2 quadrant does this have in common? Quadrant 4. That's the quadrant where sine goes negative and cosine goes positive. Number 2, where's the sine positive? Well, the sine is positive in quadrants 1 and 2. Where is the tangent negative? Well, it's positive here and here, so it's negative in 2 and 4. So what 2 quadrants did this have in common? Quadrant 2. Where is the sine positive and the cosine positive? Well, the sine is positive in 1 and 2. The cosine is positive in 1 and 4. So where are they both positive? Well, they're both positive in quadrant 1 because that's the common quadrant. Where's the cosine negative? Well, the cosine is positive here and here. So the cosine is negative in 2 and 3. Where's the tangent positive? Tangent is positive in 1 and 3. What quadrant do these have in common? Quadrant 3. Where's the tangent negative? Well, the tangent is negative in 2 and 4. Where's the cosine positive? Well, it's positive in 1 and 4. What quadrant does this have in common? Quadrant 4. And last, where's the sine negative? Well, it's positive up here, so it must be negative in quadrants 3 and 4. And where's the cosine negative? Well, it's positive here and here, so it must be negative in 2 and 3. What 2 quadrants do these have in common? Quadrant 3. So sometimes these get a little tricky, but if you break these down and get some practice, it won't be bad. Sorry this is such a long video. See you tomorrow.